Good day. Okay, so for today we are going to discuss about the molar enthalpy change of fusion. So last time I gave you the video for the molar heat of vaporization. So for now, we're going to answer for the practice exercise number 2, which is more on molar heat of fusion. Okay, so let me, alright, let me fix this one. Okay, slideshow, setup slider. Alright, okay. So we have here the different tables of an element, especially for solid, and of course for the molecular solids, non-polar molecules, and etc. So marami yan, okay? So you're going to look here for the enthalpy of fusion. This is the enthalpy of fusion, okay? Enthalpy of fusion, which is kilojoule per mole. That is the unit for the enthalpy of fusion. So we have a different enthalpy of fusion, depends on the temperature of the given sample. So you are going to look dito po sa enthalpy of fusion natin. Yan po kasi magiging part ng ating pong mismong problem solving. Okay, so we have different enthalpy of fusion with the different melting point of an compound. So, tingin kayo dito sa ating pong enthalpy of fusion if yung binigay po sa ating sample ay nandito. Okay? So, example natin dito sa ating pong slide. Ito, H2O. So, meron siyang 6.020 enthalpy of fusion or kilojoule per mole. So this is one of the commonly used actually in the molar heat of fusion, the 6.020. Okay? So, don't forget that. Pwede kayo bumalik sa table para madali nyo pong masagutan yung ating pong problem. Okay, so let's start with the, of course, the example. Okay? Let's solve the equation. So, we have here the Q. Again, this is the same equation sa ating pong molar heat of vaporization. So, different in a molar heat of fusion naman. Okay, so Q is the total amount of heat involved and is the number of moles of the substance. And the molar heat of fusion is the symbol for the molar heat of fusion. This value is a constant for a given substance. So, you're going to look back on the table because it is constant. Nandun po yung mga exact value para hindi po kayo mahirapan tignan what is the exact value of a molar heat of fusion of an compound or substance. Okay, so let's try to solve the enthalpy fusion of number 1. So let me read. The molar enthalpy of fusion of sodium chloride is 30.21 kilojoule per mole at its melting point. How much thermal energy will be transferred into the system when the 10 grams of sodium chloride melt? So this is our first example. Alright, so to calculate the molar enthalpy of fusion of a, for the first example, so we need to get all of the given. So let's try to write the given. So we have the sodium chloride, which is the molar enthalpy of fusion of the sodium chloride is 30.21 kilojoule or kilojoule per mole. And of course, we have the grams of a sodium or sodium chloride. So we are looking for the Q or the thermal energy that is involved in the equation. Okay, so since our equation is more on Q is equal to N times molar heat of fusion, so Q is missing. So we are going to multiply the following given. But first thing first, we need to do the getting the mole or getting rid the grams of a sample of a sodium chloride. So we need to convert it into gram per mole. Okay, so let me have my blackboard. So write the given. We have 30.21 kilojoule per mole. We have 10 grams of sodium chloride. So we need to get rid the gram sign or the unit of gram for us to be able to get the mole of the sodium chloride. Okay? But syempre, we need to get the molar mass of the sodium chloride. Okay? So the molar mass of sodium is 22. Molar mass of sodium is 22.9 and the molar mass of chlorine is 35.4. Okay, so if we add these two, we are going to get the 58.3 gram per mole. So this is the molar mass of the sodium chloride. Okay, so we have the molar mass of the sodium chloride, which is 58.3 gram per mole. So we are going to cancel the unit of grams, or 10 grams unit of the 10 grams. Okay, so tatanggalin natin yung grams natin sa ating pong sodium chloride. Okay, so let us move to the another blackboard. So we have 10 grams of sodium chloride times, ano nga po ulit yan? 58, right? So 58.3. So let's put this one, 58.3 grams per 1 mole. Okay, so cancel out the unit of gram. Cancel out, multiply. 10 times 1 is equal to 10. Then 10 divided by 58.3 is equal to what? Okay, so let's use calculator. Okay, so 10 divided by 58, I'm sorry, 58.3. Okay, so we have 0.17, or let's take the 0.172. Okay, so 0.171 or 172. Okay, mole of sodium chloride. Okay, so that is the mole, or the number of moles of the sodium chloride. So again, we have the different given. So we have 30.21 kilojoule per mole. We have the givens of the number of mole, which is 0.171 or 1.72 or 0.172 moles of sodium chloride. So now we are ready to use the equation of Q is equal to N times molar heat of fusion. So let me delete this one. No, gawa na lang ako ng panibagong blackboard. So let's use the equation. Q is equal to N times molar heat of fusion. Okay, so our given for the number of moles is, let's use the 0.171 mole of sodium chloride times the 30.21 kilojoule per 1 mole. So, saan nanggaling po yung 1 mole? Remember, ito po yung ating given, 30.21 kilojoule per mole. Yan po ay per 1 mole. Okay? So, balik na tayo dito. Para matanggal lang po yung unit ng mole. Ayan. So, 0.171 times 30.21. Okay, so let's multiply it. Okay? So, 0.171 times 30.21. Okay, so ang sagot natin, or final answer natin is 5.16. Okay? 5.16 kilojoule. Kilojoule lang po kasi yun lang po hinahanap natin. Okay? Or 5.17 kilojoule. Okay? So, yun lang po ang ating pong molar heat of fusion. So, madali lang. It is the same thing with the molar heat of vaporization. So, I hope nasusundan ako agad. Kung meron kayong question, i-chat lang ako sa akin pong Facebook account or sa akin pong messenger, Christian Berisa. Okay, thank you!